Inequalities can also be used to explore the ideas of intersections and unions. Here we have two different inequalities. We have x is greater than 7 and x is less than -3. X is greater than 7. We'll start with an open circle down here on the 7, and we will shade all of this region to the right. X is less than -3. We'll start with an open circle on -3 and shade all of this space to the left. If we're looking for the intersection of these two inequalities, we are looking for the space where we have double shading, where both of the inequalities are true. For this particular example, the intersection will be the empty set. There is no space where it is shaded both green and red. Contrast that to the union, and the union will be both of the inequalities together. X is greater than 7 or x is less than -3. Remember that the union is happy with anything. It just wants to see some solution in a space, and that space can be counted towards the larger solution set. And that's what's happening in this example. We have these two inequalities that are pointing out away from each other. And if we union them together, we end up with one large solution space that consists of the two smaller inequalities. Contrast that to this example. The first inequality is now x is less than 7, So we're going to shade all of this over here. And the second inequality is x is greater than -3. So here's x is greater than -3. Obviously, if we're looking for the intersection space, we're looking for the region where it is double shaded. So in this example, I see double shading in that space right here. So the intersection would be in between -3 and 7. The union of the two examples would be anywhere that is touched by either of the shading. In this case, the entirety of the number line is touched. So everything, all real numbers, make up our solution set for this particular union. And before you think to yourself, well, we left out the 7 and the -3, they weren't shaded. They actually got shaded by the other inequalities. -3 got shaded in red, and 7 got shaded in green. And now they also became part of the solution set. Our last example to look at looks similar, but we did turn one of the inequalities around again. So here we have x is greater than 7. So we're going to go this way. And for green, we have x is greater than -3. You can see the double shading space over here above the 7. So the intersection of the two of them is going to just be x is greater than 7. If we're looking for the union of the two of them, the union of the two of them is anywhere that there's any shading at all, double shaded or single shaded. Sure, this is all part of the union as well, that's the double shaded region, but we'll also want to include all of this space as part of the union. That means the union is going to be x is greater than -3. These were three seemingly very similar examples that ended up with solutions that took different forms. You want to be very careful as you graph the inequalities and look at that shading. Just a reminder that the intersection is going to be anywhere that there's double shading, and the union is going to be anywhere that there's any kind of shading.